Hi everyone, it's Doc Progeny. It's the second day of a coronavirus lockdown here in the UK, so I'm trying to do some more videos for our Progeny users to help them improve their Progeny skills. Schools are also locked down, so today I'm actually joined by one of my Progeny.
Hello, I'm Mini Progeny. Really good to be here.
And what we're going to talk about today are the operators in the spreadsheets. I've had some questions about what some of the more complicated operators do. I'm going to go through all the operators. Some are fairly straightforward and obvious, but I'd like to cover them anyway. And some are not so straightforward. So let's go ahead and do a spreadsheet. Before I start, for those of you who are using the web version, this is the PC client version. It's Progeny 10 and it's used on a Windows machine. So here we go. Individual spreadsheet. I'm going to do a fairly straightforward spreadsheet. First name, last name, date of birth. And just so you can see what that looks like, it's going to produce me quite a long spreadsheet. I can see how many items there are. I've got 3,433 items. So now if I go back and I want to start using some of the operators, well, let's use the basic ones just so I can quickly show you those. So let's find anyone in my database whose first name is Jeff, for example. So I run that, pulled up just one Jeff in my database. So go back, you'll notice how I pushed the field down into the query. I just go hover over it and it will come up with these items for sorting, deleting, or in the case of this, add field to query. That's what I did to get that down here. So similarly, does not equal. I can run that and it's going to show me everyone whose first name doesn't equal Jeff. So it's pretty straightforward, pretty obvious. So if I want to use some of the other operators, not all of them work with every type of field. So let's do date of birth is less than, which means in this case it means before. So let's go and say, let's go back into the past. Let's go back to the 60s, 1964, June 24th. So this will show me anyone who's born before June, 24th of June, 1964. There you go. You can see that's pretty accurate. Again, I can always count these spreadsheets. There's 30 people in my database who meet that requirement. Similarly, I can do is greater than. That will bring me up everyone who's born after that. Again, another item, another 30 items. Okay. And you'll see if I can also, there are operators in there, greater, less than or equal, greater than or equal. When you're doing dates, all that simply means is someone who's born on that date will also be included. Okay, it's pretty obvious. So it begins with, let's take away the date field, drop down the name field. So it begins with, well, let's do JA in this case. So anyone's name begins with the letters J and A. So that will pull up Jane here, Jamal, St. James is a Jasper there. It's pretty, again, fairly straightforward. Do the opposite, doesn't begin with. In this case, anyone whose name doesn't begin with that is also shown as well. So again, pretty obvious. Ends with, similarly, so for example, two F's at the end should pull me up for Jeff. Yep, it does. Doesn't end with FF will bring me up everyone apart from Jeff, basically, in this case. Okay, great. So that's working really well. So then really what we're looking at in terms of the interest of these last three sets contains is pretty straightforward. So if I put MA, any name that contains MA will come up. So if I run that, so you see Telma with an MA at the end, Man, Marnie, they've all got an MA in them, so they all work. It contains, again, pretty straightforward. Doesn't contain, there you go, brings that up, the opposite version of that. So, okay, so what about the really harder to understand? Well, in is really useful. So this is probably one of the most useful operators we have for people who are working with pick lists and samples and things like that. But in terms of names, so say I want to pull up every person in this list. So James, Jeff, Jasper, for example. If I run that, you'll see it's then going to pull up a specific list only of those people. You'll notice I had some James H's and James G's. I can have those. You're allowed spaces in these. So James G, James H, run that. And you'll see I also picked up the names, those names as well. One thing to note is you mustn't have spaces after or before the comma. It's got to be exact match within those commas. This, like I mentioned, is really useful for sample picks. So you can bring in lists from comma separated files from Excel, for example, cut and paste into this value and pick out that complete list. Really useful. Of course, you could do a slightly more long-winded. You could do first name equals Jeff, or first name equals James, and you could build it up like that. This is just a quick, easy way of doing that. And if you're working with hundreds of entries, it makes it much more realistic. Okay, so the last operator is like, and this is really the most complicated one. I actually had to look this up myself because it is quite complicated. So I picked up this particular URL, and this is from the Sybase's own website, and it actually will give you the description of how you use this. And it allows you to, excuse me, use wildcards and do more complicated things. So let's do something a little bit complicated here then. So in this case, we're going to use the like operator. I'm going to get rid of that information I've done. So I want to find anyone who is a James or a Jane. So see what I've done here. I've done JA, open square brackets, M and N. So what in that square bracket, the value has to be an M or an N, followed by an E, followed by a percentage, which means Jane is okay. It just has nothing following, and James is also okay. So if we run that, you'll see it's pulled up all the Jameses, but it's got a wildcard at the end. So James H and James G also count, and it's also picked up Jane as well. Okay, so that really worked well. You can obviously do is not like, and it will do the reverse of that query. So going back here, there's another interesting one here, which is for all names beginning with such a letter, but don't have the letter C as the second letter. So that's okay, but it's not going to work well for first name. So let's flip that. Let's delete that. Come up to the top, add the last name to the query. So we'll use the like operator again. So it's M, open square brackets, the little up hat, C, close square bracket, percent. So any name begins with M, doesn't have a C as a second letter, and then anything following that. So anyone who has like that Scottish Mc or Irish Mc won't be found, but everyone else will. So let's run that, and you'll see quite a few names here, beginning MI, MA, they're all fine. If I edit that and get rid of the trailing part there, you'll see we've got a McKee there. There's no other Mcs in my database. So it's doing exactly what it says. It could be quite useful when you want to exclude. So this website has got some descriptions of how you run these like operators. Quite useful. So for example, a nice one here, for example, there's an example of Carson. You're not sure if, or Christina, for example, where it's beginning with a C or a K and you're not sure. You could use those square brackets to do that search and find that particular person. Okay, so that's all for today. As always, if you have any questions or you'd like to have a video on a particular subject, don't hesitate to email us at progenyeurope@progeny genetics.com or send a message through YouTube. Of course, if you're not subscribed to our channel, please do. Like I say, we're going to be trying to do quite a few more videos over the coming weeks during the lockdown. Otherwise, stay safe and coronavirus free, of course. And goodbye from me. And it's also goodbye from
Mini Progeny. Bye.